Hi, I'm Veda, and in this video I will talk about the concept of area under the curve and how it is applied to solve problems in physics. For instance, finding the displacement from a velocity time graph.
Have you ever wondered how a car's speedometer reading over time can tell us how far it's traveled without even looking at the odometer? The answer lies in a powerful idea. The area under a graph can reveal real physical quantities. Today, we'll uncover why the area under a velocity time graph equals displacement and how this simple idea unlocks much of classical physics. Velocity is fundamentally defined as the rate of change of displacement with respect to time. This means that if we know an object's velocity and the duration it traveled, we can calculate its displacement directly. The formula is straightforward. Displacement equals velocity multiplied by time. Visually, on a velocity time graph, this calculation corresponds precisely to finding the area of a rectangle, where height is velocity and width is time. Consider a car moving at a constant velocity of 20 kilometers per hour for a duration of 5 hours. To find the total displacement, we simply multiply 20 kilometers per hour by 5 hours, which gives us 100 kilometers. This demonstrates that the area under the velocity time curve directly represents the displacement. For constant velocity, each unit on the time axis, when multiplied by the constant velocity, contributes to the total distance covered. Now let's explore scenarios beyond constant velocity, starting with constant acceleration. When an object undergoes constant acceleration, its velocity increases uniformly over time, creating a ramp-like shape on the graph. In this case, the area under the curve forms a triangle, and its area still represents the total displacement. The base of this triangle is the time elapsed, and the height is the final velocity achieved. But what happens when velocity isn't constant and acceleration isn't uniform? For irregular velocity time graphs, where acceleration and deceleration create a curved line, we use a powerful mathematical technique, integration. Imagine dividing the area under this complex curve into many infinitesimally small rectangles. Each tiny rectangle represents a small displacement over a very short time interval. By summing the areas of all these infinitesimally small rectangles, we precisely determine the total displacement. This process, known as integration, allows us to find the exact area under any curve, no matter how complex. So, whether it's constant velocity, constant acceleration, or a highly variable motion, the area under the velocity time graph consistently provides the total displacement. This fundamental principle is a cornerstone of classical physics, enabling us to understand and predict motion in countless real-world applications. Thank you for joining us in exploring the powerful concept of the area under the curve.